Good day, everybody. Hey, I'm here in MATLAB Online. Okay, so you can get there. You can always get there by typing matlab.mathworks.com. Okay, and I would put a bookmark there in my web browser if I were you, because we'll be using it a lot, and the online version of MATLAB is very good. Okay, what are we going to do here? Well, I've got a couple of tabs already open. What you would probably want to do is go new and then go live script, okay? And you can see home has certain things, but if you click on the live editor tab, it gives you all kinds of ways to enter text, right? So this is code. Um, and if I want to execute the code, I can hit Control Enter. There's not much there to execute. Um, if I want to type some text, I can do so. And then if I want to go back to entering code, I can do that. So click on text, click on code. There's all kinds of, there's bold and italics and underlining and bulleted lists and all kinds of things that you can do um, with the editing functions here. Okay, you can always click on run, which will run all of the notebook, right? Or you can step through it step by step. Again, Control Enter will also just execute the code block you're in. And so those are just a couple basics there to help with learning the MATLAB stuff. And again, I suggest being in a live script. So go new live script. Why? Well, that just gives us the most options for the kinds of things we want to do, and you can save these, right? So if I click on save, it will bring up the different things that I have saved, and I can go ahead and type a name. And you'll see that MATLAB Online actually has a list of files. I've minimized this, but you can save this so you can work along with the video. For example, it would be a good idea to go ahead and open MATLAB Online, do the video, and then you can save whatever you think is important from this lecture, and you'll be able to go back and look at it at any time that you want to. So, okay, there's enough. I'm just going to X out. I'm not going to save my changes because I already have created some work here that we can do. Um, and yeah, the first thing we want to learn to do is, how do we enter a matrix? Okay, so I'm going to make a real basic matrix. And so I'm going to do A equals. So the name of the matrix is going to be A, and equals is the assignment operator. I just tell it what it's equal to, and I'm going to use the square braces. Okay. And I just am going to separate the entries by spaces. And for the moment, I'm making a real basic matrix, okay? This is matrix A, and when I click on run, okay, so that enters the matrix, and you can see the output here shows us, oh, hey, I've got matrix A, and this is what it is. All right, so good, 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 good. All right, and we're going to talk about addition and subtraction of matrices, which happens component-wise. And we're going to need another matrix. So why don't we do that? I'm going to come in here and I am going to get another code block. Why? Well, I want a B matrix. Okay, so B is, I'm going to do the exact same thing. And so I'm going to have 1, 0, and -2. And then a semicolon separates the rows. So at the end of each row. And I will admit that up here, I tend to enter matrices like this because I think in terms of the rows. I just find it easier to enter it that way because it looks more like, the output. It looks more like what I want it to look like, and it helps me. But you don't have to. You can enter everything all on one line, which is what I'll do here to show you guys that. Let me get rid of the ink on the page and jump back in, and let's do a -3, a 1, and a 4. Okay, so I can also enter a matrix just all on one line. And when I enter it, you see that it still interprets it, right? It has the semicolon here, which separates the rows, right? The semicolon's right in here to let it know, to let MATLAB know where the second row starts. So you can enter these matrices either way. And that is purely by choice, okay? And what do we mean by adding and subtracting component-wise? Well, if I'm going to add A plus B, it's going to take the first row, first column entry from A and add it to the first row, first column entry for B. And that's going to be the first row, first column entry for the sum. So 2 is going to be the sum. And then we go across the row. So we'll add 2 and 0. So the first row, second column entry in the result is going to be 2 as well. And then 3 plus a negative 2 is going to be 1. So 2, 2, 1 should be our first row. Let's see if we can do that. Oh, by the way, this command window, you can minimize it if you want. Again, it's always there, so you can click on it as you need to, and you can get rid of it just by clicking on it. It pops open, pops closed. Okay. What can you do? Well, you can execute a command and see that it works, and then put it into your live editor and save it. Oh, by the way, anytime you want to hit save, that will save it, and that is a smart thing to do, especially when you've got correct things. Okay, so let's make a matrix C equal to A plus B, and we said that the top row of C ought to be 2, 2, 1. Let's see if we got that right. Yes, we did. And notice that, all right, that we add the second row, so 4 plus the negative 3, that'll be the 1, and the 5 plus 1 gives me the 6, and 6 and 4 gives me 10. So that's what we mean by adding component-wise. But it also means that if we add these two matrices, if we want to add them, they have to have the exact same dimensions. So notice that A has 2 rows and it has 3 columns, and so B has to have 2 rows and 3 columns if I want to add them. They have to have exactly the same number of rows and exactly the same number of columns. That's what we mean by the dimension of the matrices. Okay, and then subtraction works the same way. It goes component-wise, same rules apply. We have to have the same dimensions. So for example, let's say that D equals A minus B. And this is a little tight on the screen, but you can see what's going on. So A minus B, the first row, first column entry for D is going to be 1 minus 1, which in fact is 0. And then the second row, first row, second column is 2 minus 0, so we have a 2. And then we have a 3 minus a minus 2, so it does make that 3 plus 2 equals 5. And so you can see that that's what we mean by adding and subtracting component-wise, which requires that the matrices be exactly the same dimensions. Okay, so multiplying a scalar by a matrix, okay? So that means we're going to take a real number, multiply it by the matrix. For example, you can see D right above here, the 0, 2, 5 first row, 7, 4, 2 second row. So what happens if I take 5 times D? And how do I do it? I just use the multiplication operator, is the asterisk. Okay, I just do 5 times D, and what happens? Well, it's going to go through and it's going to multiply 5 times each of these numbers. So the top row will be 0, 10, 25, and the second row will be 35, 20, 10. All right, let's see if I got that right. And let's run this, boom. And yeah, that is what I predicted. So that's what we mean multiplying a scalar times a matrix. Okay, and why do we say scalar? Well, it's usually a real number in this class, I'll admit that. But it turns out it could be a complex number depending on the application in mathematics or engineering or science, whatever we're doing. We may require, and we can have complex numbers in a matrices. Now, we're not going to deal with those much, if at all, in this class. But that's why we use the word scalar instead of just saying real number. It just means a constant that is a a real number usually and can be a complex. Okay, and that's how it works. And by the way, it's the same thing. It turns out that this kind of um, multiplication by a scalar works the same way, whether the scalar is first or second in the. So it turns out that this particular kind of multiplying is commutative. Okay. But now, how do we multiply two matrices? Well, let's jump back. We want to do A and B, but let's print them out for a second just so we can see them again. Sorry. Okay. The problem is that we can't multiply these because they're not the right dimensions. So we're going to actually multiply A times B transpose. What is B transpose? And by the way, you can get this. The word I'm saying is transpose. You can get this way. Transpose of B. And what does it do? It flips the matrix across this main diagonal. Okay. And so if I'm taking a matrix like A and doing the transpose, right, it's going to swap the 2 and the 4, right? And it's going to take the 3 and put it down here. It's going to take the 6 and put it over here. So the transpose is just flipping the entries across the main diagonal. The main diagonal entries stay the same. And the key for us, as you'll see in a moment, the key for us is that the transpose of B is a 3 by 2 matrix. So A is still 2 by 3, but so what I'm saying, it's 2 by 3. And the transpose of B is 3 by 2. It has 3 rows and 2 columns. Okay? And it turns out this will work. I can actually multiply this, and also MATLAB has a quick code, right? If I do B, I'm doing a single quote, right by the enter key there, doing a single quote. It just means B transpose. Okay, so I can type transpose parentheses B and get the same thing, but B um, B prime, I guess. I don't know exactly what we'd call that, but B followed by a single quote will also give me the transpose. And why do I need them? Well, let's talk about that as well. Okay, let's talk about what the answer is, and then we'll let MATLAB do it. To multiply, right, and let's say that, I don't know, let's say that M is going to be the answer here to A times B transpose. Okay, so it's first row, first column entry, right? The thing that'll go right here. How do I get that? Well, I take the first row of A. Why? Well, because it's the first matrix listed. And I multiply it by the first column of B, right? Because B is listed second. All right. And what I mean by multiplying them, let me erase this. And I'll put the number there in just a second. Okay. So I'm going to multiply the first entry by each other. So 1 times 1. And then I'm going to add what happens when I multiply the second one. Well, 2 times 0 is 0. And then the last one, so 3 times -2 is -6. I'm going to add that. So the first row, first column entry of the multiplication is going to be -5, right? Okay. And how do I get the first row second entry? Well, I take the first row times the second column. Okay, how does that work? Same way, I take first component plus times first component, so I have a -3. And then I take the second component times the second component, and I add that, so I have a plus 2. And then third components are 3 times 4, which is 12. So I'm adding 12, which I believe will be 11, right? Minus 3 plus 2 is -1. -1 plus 12 is positive 11. So the 11 is going to be the second one there. Now, how do I get the second row entries? Well, I multiply by the second row of the matrix A. So doing the second row first column is going to be 4 plus 0 plus -12. 4 plus 0 plus -12 is -8, I believe. So I'm just doing this in my head now, but I'm doing the same thing. Second row times second column is going to be a -12 plus 5 plus 24. So that's -12 plus 29, which is 15 maybe. Sorry, again, doing that in my head. So why am I doing it in my head? Well, because we can have the computer do it for us, right? I can do A times B prime. And okay. And you can see the answer right here, which is exactly what we had calculated here. Oh, it was, gotta think about that. It was minus 12 plus 29. Yeah, which is 17, not 15. So I did, I did the math in my head incorrectly. But I did want to write this out so you could see what's going on with this matrix multiplication. Yes, the computer will do it for us, but you do need to know how it works so you can do it yourself by hand when necessary, okay? And so that's all we have. That's just the basic stuff. I wanted to show you a little bit about how to use MATLAB and how to do a little bit of formatting, how to do both text, right, and code, and how to switch back and forth between them, okay, how to run things and step through. You can use the run to end option, and it will, from wherever you are, it'll run to the end of the section. Yes, you can insert, right? If you go to the insert menu, you can insert section breaks, and so there's a lot of fairly sophisticated things you can do. You don't need, I've tried to just show you the basics here. And that's section 1. Let's learn the basics. And I'll be right back with a video for section 1.2, which is all about simplifying matrices with row reduction. See you soon.